All right, now we said in lesson 12.3 we're going to look at tangent lines and velocity. If you want your Desmos calculators, I was just using a blank one, but you could scan that QR code and get right there. So some words we'll get is a tangent line, instantaneous rate of change, difference quotient, and instantaneous velocity today. The tangent line, what I want to talk about that first, it's kind of like this idea of that if you had a shape, let me just clear these out of here. If you had a shape such as like a circle, let me use a circle real quick. We'll just say the circle has a radius of 5. A tangent line is a line that touches another object and it only touches it exactly one point and then goes off. So it doesn't cut through it. So here would be something that's not a tangent line. Specifically, we'd call it a secant line. A secant line would be a line that cuts through an object and hits the object 2 separate times. So 1, 2. Since it cuts through, that would be a secant line. A tangent line, however, is a line that touches an object just exactly at one point, just like that. So let me give you another example of a secant line. Y equals x. This is a secant line that cuts through the shape 2 different locations. However, if I were able to shift this line over just to the perfect spot, let me do it this way. R equals cosine theta. We could come up with an equation that would be a secant line if it would just barely touch it. That's a secant. A tangent line is if it were just barely touching it. So as we started looking through this, we would have to shift this value over just so it barely touched that circle, which we're going to learn how to do today. So this one, if I start, whoops, I meant to do +2. You can see we can get closer and closer saying, all right, so it's got to be something that's a little bit closer, but as I zoom in, I find out it's still secant. Right now, what I'm doing is guess and checking. Today, we're going to learn the math to do this exact. So let's get started with lesson 12.3. It says this: for an instantaneous rate of change. The instantaneous rate of change on a graph is given by, or the slope here of a point is given by the limit as h approaches the value 0, the limit of f of x plus this h minus f of x divided by h. Now, this means that as h gets closer and closer to 0, you can find how fast the graph is changing, whether going positive, negative, or staying constant at the point x comma f of x. That's the x, that's the y, x, y, and the slope m of the tangent line. That will be the slope of the tangent line. So when we take a look at this problem, I have here the graph, and I've shown you, here's the secant line. It's touching this parabola, just one point at 2, 5, and it's going through just exactly. And so what we're going to do is find the slope of the line at this graph at 2, 5. So to solve this, we're going to use that formula that was just shown on the previous slide, that the slope is going to equal the limit as h approaches 0 of the function f of x plus that h value minus f of x all divided by h. That's the formula we're going to use. So if I want to find this value at 2, that means my x is 2. If you plugged it in, you'll see the y is 5. 2 squared is 4, plus 1 more is 5. What I would do is I'll substitute in the values. So I'm looking for the limit as h approaches 0 of, and now f of x, so f of 2 plus h minus f of 2 divided by my h, which is ultimately going to be 0 or approach 0. So I'm starting here. So now what I'm going to do is substitute these into the equations. And this, honestly, using this formatting, I should call this f of x rather than y, or I could say y parentheses, but that would look weird. So I'm going to change that just to f there to make sense of this. So what I'm going to do is I'm going to plug in 2 plus h. And so this will equal the limit as h approaches 0 of, when I plug in the 2 plus h, I'll have 2 plus h, quantity squared, plus a 1, and then minus, and now I'm going to plug in the 2. So a minus, I'm subtracting this whole f of 2. When I plug in the 2, I'll have 2 squared plus 1. Now, since it's a positive, I don't need to use parentheses, but I'll go ahead and put them around that. 2 squared plus 1, and then I'll close that bracket, all divided by h. And so now it just becomes a game of simplifying this. What do I have here is 2 plus h times 2 plus h. We can FOIL that out right here. 2 plus h times 2 plus h. When I FOIL this out, let's see, we have 2 times 2, which is not 2 times 2 is 2, is 4. There we go. 2 times h is 2h. H times 2 is another 2h. And then h times h is h squared. So this limit will be, and I'll write this here in purple, be 4 plus 2h plus 2h. Right there is 4 h's plus 4h plus h squared. And then we're going to subtract 4 squared plus 1. Subtract, not 4 squared, 2 squared is 4 plus 1, which means we're going to subtract 5. All this is over h. So now if I want to simplify, you might be thinking, is there a shortcut for this? Yes, we will learn there is a shortcut. This will end up, when I combine my like terms, here I'm going to have an h squared plus a 4h, and then I have a 4 minus 5, which is basically -1, all over h. And I just realized I forgot to add this little 1 right here. This little 1 that was right here needed to add in plus 1 here, plus 1 there. And so ultimately, I messed up on this. Let me take that away. This 4 gets simplified with this 4, and this 1 with this 1. There we go. And so now if I solve this by factoring, we could say that this is equal to the limit as h approaches 0. What I'm going to do here is a GCF. In the numerator, we have an h that's common. So it'll be h plus 4 over h. And now I can say, okay, these h's simplify with one another. So this is equal to the limit as h approaches 0 of h plus 4. Now that I have this as a polynomial, I can substitute in directly and determine that the slope will equal 4. M is the slope. Like this whole time we were saying m equals this, m equals this. This is the slope. And so our slope here equals 4. And so this tangent line would have the slope of 4. You could write the equation of this line if you use point slope form as y minus the y value, which is 5, equals the slope 4 times x minus the x value of 2. This is using the form y minus k equals m times x minus h, where this is your h and k. So this would be the equation of the line right there. And you could distribute this out if you wanted to write it in y equals mx plus b slope-intercept form. But there it is, the equation of the line. They wanted the slope. We got the slope as 4. So now that you've seen how it works in long fashion, I'm going to let you try this one time, going about it the long way to check your work. And by the way, I guess from here, I could have, let me just show you graphically that we did get the correct answer. It was y equals x squared plus 1, and we're saying the equation is y minus 5 equals 4 times x minus 2. And when you look, certainly as it is, this line, the blue line, the red line just barely kiss right here, but I only touch one time like that. They don't cross over to make it this a secant line. A secant line, again, would be something that went through multiple times, kind of like this graph here. That would be a secant, but this right there is a tangent line. Now I'll let you work on this one. Pause the video if you need more time.